Okay, so we're going to look at this example of low resolution NMR. So in this problem, we're given a lactic acid, which is this formula. It asks, state the number of peaks in the low resolution NMR of lactic acid. So right away, I know that this hydrogen is in the same environment as this guy and as this hydrogen. And then this hydrogen, it has nothing similar to it, nothing, any other hydrogen has the same environment as this guy. So this is a different environment. This H, this H is in a different environment than this H. So in total, I'm going to have 4 different hydrogen environments. So my answer would be 4. So this is 4. And then it asks the hydrogen of the alcohol group in lactic acid produces a single peak in the proton NMR. Give the chemical shift you would expect for this peak. So this is the alcohol group. So I'm going to go into the data booklet and I'm going to see that alcohol, the H of the alcohol is in the range between 2.0 to 4.0. So I'm going to answer here the chemical shift is between 2.0 to 4.0 ppm, and that's the answer. And in this example, if we were to figure out how many different proton environments we have here, for this molecule, these 3 hydrogens are in the same environment. This guy is in a different environment than this. And lastly, these 2 hydrogens are in the same environment. So we have 4 different environments. In this case, again, this is in a different environment. This is in another different environment. However, these 3 hydrogen and these 3 hydrogens, so total 6, they are in the same environment. So for this guy, I'm going to have 3 peaks in low resolution NMR as well as high resolution NMR. For this guy, I'm going to have 4 different peaks. And in this case, I have this 3 in a different environment, then this, as well as this. So I have 4 different environments here. Although these are the same group, but they don't have the same neighbors. So they're in a different environment. This CH3 and this CH3 are in different environments. In this case, this is interesting because these 3 hydrogens have the same neighbors as these 3 hydrogens as well as these 3 hydrogens. So all of these 3, it's 9 guys. So these are going to have only one environment. Okay. So if we were to sketch this using the data booklet and chemical shifts in a proper way, the way we would do this is, for this guy, these are just normal alkane peaks, right? These 2 are normal alkane peaks. So I'm going to have 1 peak for the blue one, which has a height of 3, 1 peak for the purple one, which is a height of 2, and then I'm going to have a different chemical shift for this one. So because this hydrogen is bonded to a carbon that is bonded to a nitrogen. So if I go here, if I see that this is the case, the hydrogen that is bonded to a carbon which is bonded to a nitrogen. So this is going to have a different range, say around 2.4 to 3.5. So this one is going to have a different chemical shift from 2.4 to 3.5, and its height is going to be 2. And this is the hydrogen with nitrogen. So I'm going to go there, and here it is, a hydrogen with a nitrogen that is bonded to a carbon. It's a normal amine. This is not, there's no benzene ring attached to the nitrogen, so we're not going to look into this. So don't get confused. We're looking into this one. This is our range. So it's going to be, say, around 0.5 to, I would say 2.8. 0.5 to 2.8. So this guy is going to be, the height is going to be 2 because there are two hydrogens, 0.5 to 2.8. So if we were to sketch them, so the blue one, so alkane's range is here, 0.1 to 1.9. So this is going to be, so both of them are going to be 0.1 to 1.9. Okay. So this is the plot. So this is chemical shift. The TMS is at 0, and this is 12. So if we have 1, 2, 3, 4, let's just say, and goes on. 1, 2, 3, 4, and this goes on. So what we do now is I'm going to draw the blue one first. So this is going to be between 0.1 and 1.9. So somewhere here, I'm going to have a peak that has a height of 3. Let's just make this a little bit longer, taller. And then I'm going to have a purple peak around the same region that has a height of 2. And then I'm going to have a light blue peak that has a height of 2 and in the range 2.4 to 3.5. So 2.4 to 3.5 somewhere here is good. It's going to have a height of 2. And lastly, the two hydrogens with the nitrogen, it's going to have a height of 2 and in the range 0.5 to 2.8. 0.5 to 2.8, so somewhere here. So that's good. So mention the heights always. So this is 2, this is, just going to take the appropriate colors. This is 2, this is 2, this is 2, and this is 3. So that's that. So I'm not going to show this one, but I'm going to talk about this one. So if you were to draw this one, so these hydrogens are bonded to a carbon that is bonded to a nitrogen, so which is the same case as this one. So it's going to be between 2.4 and 3.5. So these guys are going to be between 2.4 to 3.5. So let me just check if that was correct. So yeah, 2.4 to 3.5, somewhere there. Okay. And their height is going to be 9, right? Because 9 hydrogens are producing this peak. So if you have a chemical shift, if you have to sketch a chemical shift, so this is 0, so this is TMS now. This is TMS at 0 chemical shift, it goes all the way to 12. And we want something between 2 and 3.5, 2.4 to 3.5. So first scale is this, 1, 2, 3, 4, and then it goes on. Just it's not to scale, but just imagine if it is. So now I'm going to have a peak between 2.4 and 3.5, so 3 is a good place, and its height is going to be 9. They are in the same environment.